Hello again everyone. The topic which we are going to start today is the micrometer screw gauge or just screw gauge. Like vernier calipers, this is also one measuring instrument, but it is much more accurate than vernier calipers. Remember, in vernier calipers it had two scales, the main scale and the vernier scale. Here also we are having two scales, but one is main and another one is your circular scale. Let's see the diagram. This is how the instrument looks, alright, and this can be used to measure even the thickness of your hair with an accuracy of about 0.001 centimeters. So how it works, whatever you want to measure, you will place between the stud and the spindle here, and then you have to rotate the head, and due to that the spindle comes closer to the stud and the object of which you want to measure the thickness, it gets squeezed between the two. Alright, and after that you have to measure the main scale and then the circular scale, and then use the formula to calculate the observed reading or the correct reading. Alright, now the main parts are, as you can see, stud, spindle, screw, nut, sleeve, main scale, baseline, circular scale, thimble and ratchet. It is important to know some of their functions, especially the sleeve. If I have to ask what is the function of sleeve, sleeve is a part where the main scale reading is graduated. Alright, and you see what is main scale, small divisions here, each of 1 millimeter distance. Alright, that is your main scale graduation, and the line on which it has been graduated, that is your baseline. See this line, that is your baseline. And then we have another scale here which is marked like this around the circular scale. Right, that is your circular scale. Alright, all the way. This is your circular scale. Then you have the thimble and the ratchet. Now what is the use of ratchet? This is important because when you place something between the stud and the spindle, and when you are tightening it up, the spindle moves, the screw moves towards the object and it is getting compressed. Alright, it is important that we don't squeeze the object too much, otherwise it will get compressed and its thickness will be hampered. So ratchet makes sure that as soon as the object comes in immediate contact with the stud and the spindle, it makes a rattling sound. That means it won't move any further. Is that okay? Now let's start with the principle on which it works. Alright, this device, alright, the principle here states that when you rotate the head, the screw, it moves forward, linearly it moves forward. Suppose you are rotating it from this side, alright, the screw, suppose from point B it reaches point B dash till here. Alright, so the distance which the screw moves when you give one full rotation, you are rotating it like this, one full rotation. One full rotation means if you see this 95 mark here and I am rotating it, this 95 mark goes all the way back and comes again forward to that same previous position. That is one rotation. On doing so, the distance moved by the screw will always be equal to the distance between two consecutive threads of the screw. So these markings here, these are the threads. Alright, so to understand much more clearly, you pay attention on this diagram. If I am giving one full rotation, the screw, suppose it moves to a distance x here. On one full rotation, the distance traveled is x. Now this distance has to be equal to the distance between two consecutive threads here. So this also has to be how much? It has to be x. This is the principle. Alright, the second topic, so let me repeat it once more. The principle on which screw is based that the linear distance moved by the screw when the head is given one complete rotation has to be always equal to the consecutive distance between the threads. That is the principle. Alright. Second topic you have to understand is the pitch. Now pitch is nothing but this distance x. You can call this as pitch. Pitch is nothing but the distance moved, the distance which the screw moves when it has been given one full rotation. So other way you can define it is that distance is pitch is just the distance between two consecutive threads. So there are two ways by which you can define the pitch. First one is the distance moved by the screw linearly when it has been given one full rotation. That distance is called pitch, or you may call it as the distance between two consecutive threads. Generally, you note it down, the pitch of the screw pitch would be just 1 millimeters or it would be 0.5 millimeters. Now why do we have two values here? Because sometimes this is just an instrument, alright? It is not necessary that it will have 100 divisions on the circular scale every time. For in this diagram, the total reading of the circular scale, as you can see, is 100. This is 95, 96, 97, 98, 99, until here it is 100. But there are some other instruments, depending upon the model. Sometimes they have 50 divisions. 50 divisions would be there, then instead of 95 you will see here 45, between 0 and 45, and then the next reading would be 0 here. So here in this one, the total number of divisions on the circular scale is 50. Is that okay? Now depending on that, if you have to calculate the pitch, always keep in mind, alright? If you are calculating the pitch, suppose for an instrument, if circular scale divisions are suppose 100, then pitch in this case would be 1 millimeter divided by number of rotations you are giving to it to move the screw 1 millimeters. Alright, that means how many rotations you will give such that the screw moves just 1 millimeter ahead. So if there are 100 divisions, clearly you will give only one rotation. So the pitch here would be 1 millimeter. Is that okay? If circular scale divisions are 50, now if there are 50 divisions, in order to make it move by 1 millimeter, you will have to now give two rotations, 50 and 50, that will make 100. So in this situation, the pitch would be 1 millimeter again, divided by the number of rotations you are given, that is 2, that is 0.5 millimeters. Is that okay? Another way to understand it, just you can think, because these threads, sometimes they might be marked, the distance between them would be just 1 millimeter. That is for the case when there are 100 divisions. If there are 100 divisions altogether here, now 95 to 0, that is 100 divisions here total, then in that situation the distance between two consecutive threads would be 1 millimeter. Is that okay? So the pitch will be 1 millimeter. Remember the definition, pitch is the distance between two consecutive threads. If there are 50 divisions, that means I will write here 45. If there are 50 divisions, then the distance between two consecutive threads would be just 0.5 millimeters. Now if you know how to calculate pitch, it is very easy to calculate the least count. Alright. Now least count, firstly you see the formula. Least count is pitch divided by total divisions on circular scale. Using this formula you can calculate the least count of the instrument, but before using that formula you try to understand what least count means. Okay, now least count, just erase it. Least count means that if you rotate this head just by one division, suppose here the mark was 95, if you rotate it in such a way that this 95 mark, it moves just by one division, it reaches here. Alright, in that situation the distance moved linearly by the screw here, the distance which is moved here, this distance, the measure of that distance would be called its least count, and that would be just already I have told, it would be 0.001 centimeters. That is the least count. Okay, you can just check it out. The least count here, suppose for 100 circular scale divisions the pitch is 1 millimeters. So using the formula pitch 1 millimeters and total number of divisions on circular scales, it is 100. So this will be 0.01 millimeter, or you write it in centimeters, it will be 0.001 centimeters. Is that okay? Now suppose in in this one you are doing. Again for this one you calculate this from pitch is 0.5 millimeters, but the number of divisions on the circular scales, remember I told, if it is written here na, total number of divisions on the circular scale, it is 50. So you write here 50 using this formula, pitch by total divisions on the circular scale. Again you calculate, again you get 0.01 millimeters or 0.001 centimeters. So that is how you calculate the least count. I hope the topic is clear.